Okay, thank you. Okay, so real quickly, thanks again for listening. At least I hope you will. I'm going to talk about how LANDFIRE uses SyncroSim, STSim to update the spatial data layers that it produces. And I'm actually just going to talk about vegetation. Fuels is different. And in the time period we have, can't do all of those things. So I'm going to focus on vegetation, how we update the vegetation later. If you really want to know how fuels is done, Tobin Smales back there in the back, he can tell you. Okay. All right. Oops. All right. So that's my goal, is just to give you a brief description of how LANDFIRE update process uses it, SyncroSim. And briefly, what, why, when, what, how is LANDFIRE currently updating data? And then some of the new options that we're considering for how we do it in the future, because things are changing. And there'll be a couple of options. I'll focus on one, but I'll talk about both. So why and when does LANDFIRE update data? We now provide we provided wall-to-wall remaps of CONUS, Alaska, Hawaii, and insular areas. And if you're not familiar with that, insular areas is Puerto Rico, Virgin Islands, Guam, Samoa, etc. Okay, once representing 2001 and once representing 2016. Complete remap, every pixel in all those areas. But data needs to reflect current conditions as much as possible, particularly for fire, but also for other things as well. I mean, fire is not just the only thing. They are the primary consumer of LANDFIRE, but not the only consumer. But they really need data to be more current. Right now, if it was 2016, that's 7 years ago, okay? In between versions, 8, 10, 12, and 14, they're in red, were based on the 2001 data set. 8, 19L, 20, and 22 were based on the 2016 data set, the remap data set, okay? So you have to have a base for your update, right? That's the difference between those two sets. And they were disturbed, we call them updates because they modified all the layers, which I'm going to talk about in a minute, basically driven by surface disturbance, any kind of disturbance that we could find or was sent to us. So right now you're going to see that what about the undisturbed pixels? They're not changed in an update. Okay, so need to be clear about that. So those pixels are 7 years old. They haven't grown. Okay. So what does LANDFIRE update regularly? And by regularly now, I mean annually. LANDFIRE is now delivering the products annually. Now representing disturbances as much as we can find or get or sent to us from the previous year. So the data, you could say it's a year vintage. Okay, so we delivered LANDFIRE 22 last year. We're delivering LANDFIRE, sorry, we delivered LANDFIRE 2020 last year. We're doing 2022 this year. Southwest, Northwest are done. The rest of the U.S., continental U.S., oh, Alaska's done. The rest of the continental U.S. will be delivered in the fall. Okay, so what's being updated? Well, vegetation is in the disturbed pixels only. Remember what LANDFIRE considers to be disturbed. Fuels is updated. Disturbance is updated. Those are 2 blue stars. I put a white star there because that's what we're going to talk about today. Those are all updated, but you see they flow through other things. So those things they flow through will also get updated. Okay, but for disturbed pixels only. I'm going to say that probably 5 times before this is over, because that's a problem. Where I come from in the South, 7 years, trees could grow 15 feet, but they're still 7 years old in the LANDFIRE data, okay? So we also see there's 850 state and transition simulation models, pre-European colonization, vegetation dynamics, 850 in the lower 48, plus Hawaii. We don't have any for Puerto Rico, anyway. And then another 90-something in Alaska. We update those, but that's not a regular update. That's why it's in all different color stars. But this is what we're going to focus on today, real quickly, and see how it flows down into fire regime and other things, okay? So how does LANDFIRE update now? So we take some base layer, remember 2016 is what we're basing the update on right now. We find disturbances, or disturbances were sent to us. By find, I mean remotely sensed, right? Satellite imagery, whatever else we can find. We gather data from the burn programs like modeling trends in burn severity. We mine all those data sets, NIFPORs, the National Forest Plan, operations, and, facts, all these databases. We mine all those databases for disturbances and then add in what we can find remote sensing. Okay. So we get this perimeter for a disturbance. And you can find that LANDFIRE does provide the disturbance layer to you, so you know what they got and what they missed, because they provide the disturbance layer all the way back to 1999. So you've got an annual disturbance layer from 1999 right now to 2022 when it's delivered. So then if we can get it, we try to get severity of the disturbance, right? If it's a fire, was it a low severity, moderate severity, high severity fire? Was it a clear cut? Was it a thinning? Was it a total destruction by southern pine beetle, or just sort of a hit or miss? So that's a severity is kind of an important thing. This happens to be a fire that was northwest of Sacramento. I knew I had severity for it, so that's why I used it in here. So the darker the color, the higher the severity of the disturbance. And this is where SyncroSim comes in, because by treating just all these things as deterministic transitions, we can update the data from the base map layer to the current using all the disturbances that have happened since the base map layer. Okay. And that's where we start with what the vegetation type was. That's ecological system, ES. The EVC in this case, right? Cover. I'm going to talk about cover. We do it for height as well. Vegetation cover. And by the way, that's not just for trees. That's for shrub and for grass as well. The DT, which is the disturbance type, was it a fire? Was it insects? Was it hurricane? What was it? Time since disturbance, was it 6 years ago, 2 years ago, 1 year ago, whatever? And then the severity, and we have millions, literally millions of rules. Let's call them literally millions of deterministic transitions that we use to update the data continent-wide, Hawaii, Alaska, insular areas. Okay. Then you get an updated, in this case, existing vegetation cover. So you can see the cover is less where this fire was more severe. The final cover is a little bit more where the fire was less severe. That makes sense how this is done? It's just a deterministic transition within an STSIM model. Okay. So we're working on a couple of other ways of doing this, which is very similar, still uses STSIM. Same thing. What's your base map layer? What's your disturbance? What's the severity? When did the disturbance happen? But instead of using rules, we're trying to develop response curves. How does cover and height change after this kind of disturbance this many years ago at this level of severity? So instead of rules, we're trying to go to curves. I'll explain why that is in a few minutes. So it's exactly the same, except we're replacing rules with response curves. And we think we're going to replace millions of rules with a few thousand response curves. Boy, that's a hard number to say, though, a few thousand response curves. But it is 2 or 3 orders of magnitude less than the things we're using now. Okay, something that we think will be easier for people to understand and use. We'll find out. Okay, so we're doing exactly the same. This is not implemented yet, by the way. The current LANDFIRE is coming out, still using the old rule base. We're still developing this. I would say the factory is kind of built. We just need more input data to develop response curves, then operationalize the system, and then it could be used. So you're seeing the difference between the two processes, okay? There's another process, because remember, again, this is only updating disturbed pixels, right? No, that's not true. With this, I can develop a growth curve for these pixels that are not disturbed. So I can say if the cover was this in 2016, it tends to grow 2% a year. In 2023, it'll be 15% higher canopy cover. So you can actually start coarsely, roughly growing pixels using this method. We follow? Okay. All right. And so this is the response curve, and I'm going to ask Sky to look away because she's been working on this for a couple of years now. And these are examples, by the way. These are not final curves, but this is what we're talking about, where you have a type of disturbance. I think we have 7 of them. In this case, I think we're only showing 5. And then we're saying what's the time since disturbance, and then what's the percentage cover, and we use the slope and the intercept within STSIM data sheet as a way to update the data. There are also curves for undisturbed pixels. The reason these are not final is because it's really hard to get accurately located plots from things like FIA, NRCS, BLM. They're very tightly controlled, right? So we've been struggling with that because you really need accurate plot locations to say that pixel was disturbed, because the FIA might be 300, 400 meters from there, or even a kilometer. Okay, everybody follow? So that's why these are, we'll call these draft curves just examples. So using these curves, we can update disturbed, undisturbed pixels. And interestingly, we can also project into the future as far as we have data for, right? We don't want to extrapolate 100 years into the future. We have data that's exhibits this kind of range. And this is where it's going to be important that we implement this carefully so that things don't grow forever, right? You'll see we had linear curves. Maybe at some point we'll have a nonlinear curve. These things could be modified. But some of the reasons we're doing it relies on a few thousand curves, which we think are reviewable by somebody locally, rather than 100,000 rules. They can just look at a curve for madrian, pinyon, oak, pine, whatever. I made that up. I don't know what it is. Okay. Okay. It maintains the native resolution of EVC EVH that LANDFIRE provides. The rules coarsen the data in the update. As you know, I said we can project into the future, and that's going to be important for other federal systems. If you haven't heard of IFTDIS, Interagency Fuels Treatment Decision Support System, they want to look at the effectiveness and durability of treatments. So they want to project into the future, not just update to today. And eventually we'll be able to track EVC, EVH separately for herb, shrub, and tree on the same pixel. And when they transition during the succession pathways over time, okay? The other method that LANDFIRE, I think we're actually going to implement this year is not this one. It's what we call the image-based prototype, which is basically totally based on imagery. It's going to be remapping disturbed pixels based on imagery. And I think we're going to try that this year while this is still being developed, at least to find out if that will work and if we can actually use an image-based prototype coming up. And that, I think the decision was that we're actually going to do that this year. So this is still in development. But SyncroSim, STSIM is the basis for this and the way we're doing it now. And it could be a hybrid. We might do STSIM on some and image-based on some. So, because the annual delivery, that's a real production. And when you're thinking about the entire continental US trying to deliver every year, disturbances from perhaps just a few months ago, that's a real production cycle issue that you have to make adjustments for. So Lloyd, he's not totally close. So there must be at least 1 minute left for questions. I think that's pretty much it. Yeah, lots of ways to learn about LANDFIRE. If you want to, I had to replace the bird with an X. But websites, YouTube, et cetera, et cetera. So